Okay, hello everyone. Thank you for coming back from the break to attend the talk. I will be talking about two particular topics in Python. We can think of them as a journey in time. So we'll first take a journey in the recent past, and then we'll take a journey in the very near future. I was going to make a nice looking presentation, but then I thought, when else will I be in an auditorium full of hardcore programmers? So I'm going to try something new. Okay, so as Amna said, my name is Waqar Saleem. I am a faculty member in the computer science program here at Habib University. And I will be talking mainly about f-strings and assignment expressions. What are f-strings? What are assignment expressions? Let's just take a look. F-strings are part of PEP 498. I was very happy to see F-strings being used in Amara's and Amber's talks. How many people here know about F-strings already or use them? About 5 or 6 people. Okay, that's good. So hopefully once my talk is done, then the entire room will be able to hold up their hand. So F-strings are a very convenient feature in how you construct your string. They're part of PEP 498. PEP, as you know, is the Python extension proposal. So whenever a new feature is added to Python, some PEP is submitted, and then the maintainers of Python go over the PEP, and then at some point they decide to either accept it or to reject it. So the PEP 498, which introduced f-strings technically as literal string interpolation. So string interpolation is a feature in other languages as well. It was introduced to Python as in the form of f-strings. The PEP was created in August 2015, accepted September 2015, so it's about 4 years old. It's a very useful. It was officially released as part of Python 3.6, which was released in December 2016. So about 3 years ago. And the syntax of f-strings is as follows. So you construct a string. So this may look unfamiliar, but don't get scared. So you'll see. So here is the opening quotation. Here is the closing quotation. And between the opening and closing quotation, you have a long string. The first thing to notice here is that there's an F behind our string, and that F is where this feature gets its name from. It's an F string, F for format, not for any other F word. What you see here between, so an F string can contain regular text, and regular text, that's no problem. What F strings introduces to strings is this long part here. What is it? We can put an expression inside the string, and the expression is evaluated runtime, and we can provide certain options to the expression. They're also evaluated runtime. And we'll see later on how f-strings, in fact, are a faster way to format strings than the other options that Python provides. So I want to show you a few examples. I thought the best way to demonstrate them to you is through code. So let me just go into the files. Okay. So here I have some vanilla Python code. The way we'd usually format a string would be using the format specifiers. We're all familiar with this %d or %s. So people who started with Python in the earlier days of Python may be familiar with this %d and %s format. And if I run this, here is the output. So we see that the first %d got replaced with iteration, whose value was 3, and this %s for string gets replaced with conference. These are variables that we had initialized here. How many people have used the % format specifier? Quite a lot of people. Okay, good. Before I move on, because I see my both buffers are not filling into the screen, let me just ask you, if I decrease the font just a bit, is it still visible? So let me decrease it and then ask you if you can still see it. Is this font still visible? All the way at the back, can you still see it? Yes? Okay, good. So I think I'll stick with this size. Let me just maximize the window. Okay, so let me just keep both windows together. Okay, good. So this, this percent format specifier is how we used to format our strings earlier. Then came the string format, where we have essentially the same string, but now instead of %d and %s, we have these placeholders. And where do those placeholders get their values from? They get their values from here, what we provide to the format function. And if I run this, then no surprise, here is my output. It's the same as before. But the way I formatted my string is different. F-strings introduce a newer way. So this is now the F-string version. And you will notice now that, so the F-string is, like I showed earlier, we have as before the F to indicate that it's an F-string. We have the string enclosed in our quotation marks. And inside we have the placeholders, similar to how we had here. However, here the variables are inside the string. And that this is what F-strings offers. We can have expressions, and then we'll see more expressions that we can put inside the string, and then they get evaluated at runtime. So when I run that, here I get the same output, but you'll see that in all of these three cases, I constructed my string differently. And the last version is the F-string version. I don't know about you, the first time that I saw the F-string version, I was pretty much blown away, because I thought, here I'm putting my variable in the string and it's getting evaluated at runtime as part of the string. That was, for me, it was quite an experience. Okay, there's a lot more we can do with F-strings, so we can put not just variables in there, we can put a whole bunch of stuff. Let me show you some of that stuff. We can put we can put constants in there. So here we have an S-string where inside the braces I have maths.py, and here I have a full-on expression that will do some certain computation, and then that gets output. So if I run this now, you see here, we got the output, and so here is the radius part, which is coming from. So this radius is coming from this evaluation, and then there we can't see that. I should do something about that. Here we can't see that, but here this part is coming from the computation over there. There probably is something I can do about this. Okay. What more can we do with these expressions inside the F-strings? We can use dictionaries. So here I have set up a regular dictionary. It has a key called conference, which has a value of Pycon Pakistan. We have another key called iteration with the value 3. And I'm going to print the same string as before, but now I'm going to, inside the expressions that I evaluate, I'll put a key retrieval from the dictionary. So here you see I get the values that I got here. This time this 3 here comes from the dictionary evaluation, and the conference name also comes from the dictionary lookup. So I'll similarly be showing you some other things that we can put inside the F-string expression. We can call functions inside the S-string. So here is a guaranteed random number generator. And, oops. So here this 4 comes from this function call that was evaluated in the F-string. Let's see a couple of more examples, then we'll move on. We can similarly evaluate objects, and then here I also highlight another feature of S-strings. So let me start from here. We have defined here a class conference. A conference stores the name and iteration, similar to what we've been doing so far. We just put that now in an object. There's a name and iteration. It has a string representation. It has a representation. The REPR. It has a best talk. Of course, this is the best talk. And we'll inside the string. We'll actually look at. We will look at the inside the string. We'll evaluate the object. So we instantiate here an object Pycon 3. We give it some values for name and iteration, and then we'll see how we can use this inside the string. So here inside the expression, I have this is my object that I created here. This is some new syntax. So we can strings allow for the expression to have this R and S. The R represents the R corresponds to the representation function, and the S corresponds to the string function for the object. And as before, we can just like we can call regular functions from inside the string, we can call object methods from inside the string as well. So if I run this. So this is coming from the string representation of the object. This line comes from the REPR function. This is again the string representation when we look at exclamation mark S, and this here corresponds to this method. So you see here, I mean, this is surely you can get all these outputs in other ways as well, but strings just provide you a nice and convenient way, and it's also very readable. So instead of putting %d, %s, or putting empty placeholders, someone reading the code can now directly see that, okay, here what will be output will be some representation of Pycon. Here will be some representation of Pycon 3.besttalk. Instead of the other methods where we would have empty braces here and then dot format and then whatever we need to print. So here whatever we are printing is right there inside the string. So it's much more readable. And those of you familiar with string, how many people are familiar with string format and all the different flags that string format takes? Okay, many more than before. That is good. So we can use all of those string format methods. In fact, behind the scenes, string in fact calls this the string format method. And here are some examples. If you're familiar with string format methods, these will not be new, but I thought it's good to show them anyway. So for example, here I have some datetime object, and that object I am going to output in an F string. But now I have given some options as to how this F string, as to how this object is to be evaluated. These are the same options that you would have provided otherwise to string format. So here is the output that we get from there. We can similarly we can output numbers with different amount of precision as required. So here I'm going to print pi with 2 decimal places and with 6 decimal places, again inside an F string. And there we have it, pi with so this corresponds to this S string over here, and this S string results in this evaluation of the expression to 6 decimal places. We can similarly do string and number formatting. So if you are used to string format, then all of this will seem very familiar to you. These are the same options that you provide to string format. We provide them now in the F string using this colon syntax. So here I'm just going to print out a table of powers. So here I have these strings, taking space of 2, 3, and 4 spaces, and here I print the numbers, and I've specified how many characters the numbers can take up, and also the justification within that space. And lastly, the true purpose of our lives, to find the meaning of life. So I'll make your job easier. I'll just tell you the meaning of life right here, and we look at the meaning of life through different lenses. So we look at the meaning of life in decimal, which is how we would normally see it, but then we'll also see the binary and the octal and the hexadecimal and scientific representation of the meaning of life. So there you have it. The meaning of life is 101010. You can go home and tell people about that. But again, we see that F strings makes it very easy. So you'll see in all of these F strings, I have my variable. The only thing that I changed here was the option that I provided to the F string. Okay, then I just have some notes, some cautionary notes before I move on to assignment expressions. I will not execute this code. I'll just go over this code one by one so we can understand what these points are. So we can use small f or capital F. They're interchangeable. That does not make a difference. What does make a difference is, for example, if I try to execute this code right now, line 6, that will be a problem. Could anybody guess why that would be a problem? Sorry? Case sensitive, right? So there's capital F, but then Python accepts capital F also for F string. So so small f, capital F, it will accept both of them. There's another issue. Yes, Shariq? Yes, so the issue is that when Python is reading this string, it thinks that here the string is done. Right? Whereas I want to use this code to indicate my key in the dictionary. So I say, okay, that's no problem. Let me just escape the code. Right? So that's what we usually do. We say that, okay, if this code is bugging us so much, let us just escape it. So then this will escape the quotation, this will escape the quote, and then I'm back, and all is well, and I have my key. But this will also not work. I will not run it in the interest of time, but this will also not work because backslashes are not allowed in an expression. So here inside the expression I have a backslash, and backslashes are not allowed. So this will give you some strange error, and the reason will be that you have a backslash inside inside the braces, these backslashes not allowed. So what should I do to resolve this problem? So can I just not do this? Can I not print dictionary keys? Yes. I can use a different quotation mark, right? Someone there, you had the same answer? I can use double quotations outside and single quotations inside. What I've done here is that I've used single quotations outside and double quotations inside. So that I don't run into this problem of mismatched quotations or backslashes in the S string. Or I could also have used the triple quote version, so that circumvents the whole problem entirely. Okay, this is interesting. I think I'll run the speed part. So here, how many people are familiar with the timeit module and have used timeit to time their Python code? Okay, good. So it's non-zero. That is good. So if you haven't done so, then you should. It's maybe, I mean, most of you are students, and in student life, the kind of work that you do, maybe performance is not all that important, but definitely when you go on to write production code professionally, then these things will become more important, and then you'll begin to appreciate the value of these tools. But anyway, so for now, I mean, even for those who haven't used it, suffice to know that there exists this module called timeit, which has a very easy syntax, and we can use it to time our code. And so here I'm basically timing 3 different versions of essentially the same command. The only thing that varies between all these 3 is how I'm constructing the string. So in the first version, I'm constructing the string the way I showed you earlier, using the percent specifiers, percent format specifiers. Here I'm using the string.format method, and here I'm using our friend the f string. So when we run this, let me just set things up. Okay, so you'll see. So the time taken for the percent format specifier is something. The exact number is not very important right now. The string.format method actually takes a bit more, but we see that the fstring method takes the least amount of time. So if efficiency is a concern, then you do get gains with using fstring. So that's in fact very nice. So not only is it nice to read, not only is it convenient when programming, it is also more efficient. So it's a win-win. A couple of other notes about using f-strings. So now because we are using braces in the f-string to indicate the expression that you want to evaluate, so how do we print a brace? The answer is not to escape it. The answer is that we print a double brace. So if you print a double brace, then that will show a single brace. So the way to escape a brace is with another brace. So you can play this game. You say, okay, what if I have 3 braces or 4 braces or 5 braces? So all of that you can answer knowing just 2 things. One thing is that a double brace is 1 brace, and if you have 3 braces, that is read like this. So the first 2 braces will be 1 brace that is output, and the third brace will be used to evaluate the expression inside. So if I just print this out, so here I see I see this brace because of, so this brace is coming from these 2 double braces, this 42 is coming from the evaluation of this expression, and this brace is coming from these double braces. Okay, if you're dealing with reading large files or reading data over an internet connection or any kind of network connection, then you may be dealing with raw strings or Unicode strings or binary strings. So we can mix F strings with raw strings, that works. But if you try to F string with F strings, do not mix with Unicode strings or binary strings. And we're not allowed to write comments inside the expression. So if I try to do that would fail. So this would not be treated as a comment. Something would happen, but if you're expecting this to be a comment, then this will not be a comment. So comments are not allowed inside the expressions that we evaluate in an F string. Okay, so much for F strings. Now, okay, so here are a bunch of references that that's not expected. Okay, I suppose I can just do it from here. So if you want to find out more information on F strings, you can of course always go and read you can go read the PEP. The PEP usually contains too much information, more than you want to know, but there are some good guides for F strings. There are some tutorials. You can always go and see those. The next thing I'll talk about are assignment expressions. And var folders xm something. Wow. Let me just see if I can do something about this. Hope this doesn't break anything. Oh no. Interesting. Anyway, so we'll have to see it this way. Okay, so the next thing we'll talk about are assignment expressions. Assignment expressions are, so how many of us know what assignment means in programming? What would be an example assignment? Okay, is assignment, so when we do an assignment usually looks like this. I'm sure we all know. So if I say, so this is an assignment. Altogether, what do we call this line, this highlighted part? It is, at the moment, it is not an assignment expression. It's given, it's called slightly differently. It's called a statement. So there definitely is a variable here, and that variable we are assigning a value. That's why it is an assignment statement. And assignment statements don't usually have a value. So if I do this, then fine, Python gave the value 42 to meaning of life, all is well. What assignment, okay, so that is one. Let us contrast that with, let's say this. What is this highlighted part? This is technically called an expression because expression evaluates to a value. So all those things that you're putting inside the braces in the F string, those are also expressions because they evaluate to a certain value. So this here is also an expression. It will evaluate to a certain value. This previous line does not evaluate to any value. It is just a statement. Whereas this here is an expression. It will evaluate to a certain value. And then if I press enter, Python will show me what that value is. So we see that there is a distinction between, so this was a statement and this is an expression. And usually assignment is a statement. So there are statements of many types. This is an assignment statement. So the new thing in assignment, the new thing in assignment expressions is that assignment is now an expression. What does that mean? I'll show you shortly, but just some history. So assignment expression was introduced to Python through PEP 572. PEP 572 was created in February 2018, and not long afterward it was accepted in July 2018. PEP 572, so remember how I told you how we're doing a journey in time? So F strings have been around for 3 years. They're part of Python 3.6. Assignment expressions are part of Python 3.8. How many of us are using Python 3.8? Some people are. Okay. Did I see some hands there, or is it just a light? Okay. Python 3.0 is not really out yet. There are alpha versions, there are beta versions. There's a release candidate out. Maybe you're using those. Officially, Python 3.8 comes out in 2 days. So in 2 days, well, after 2 days, when you go to python.org and download Python, then you'll get Python 3.8. If you do it right now, you'll get Python 3.7, unless you explicitly go and say, show me all builds, and then I want to download some other version. But yeah, so it's going to come out in Python 3.8, and the syntax for assignment expression is as follows. Well, you can see that here. So this is the syntax. And the syntax is as follows. So you say name colon equals expression. What does that mean? Let me write that here. So I had this here assignment statement. Let me just repeat that here. And the assignment statement does not evaluate to anything because it is not an expression. It is a statement. Statements don't evaluate to anything. So Python doesn't show me anything as a result of executing this statement. When I executed this expression, Python showed me the result of the expression. With assignment expressions, I have the same thing. Except so with some syntax, this has become an expression. It evaluated to a value. So now this is an assignment expression. It is at the same time an assignment and an expression. So it does the assignment. So the assignment statement is inside it. But on top of that, it returns, it evaluates to the value that was assigned. So this returned this evaluated to 42. If you've been keeping up with this PEP and related discussion, then this has been a very contested topic, a very contested feature. There are Reddit threads of people saying outright that they will never accept any code that contains an assignment expression. Regardless, it is part of Python 3.8. It is coming out. So once it becomes part of the standard, people will ultimately end up using it. And whenever some new feature comes out, there are always purists who say that no, this is sacrilege and no, we cannot accept it. But I'm sure we have all that. Every time Facebook changes something, then we're all very upset. But then 2 months later, we are championing it. So then coming. Okay, so what does this evaluate to now? So now that I've made this an assignment expression, what does this evaluate to? Which is the chunk itself. right? So now essentially this is doing what I was doing here. So I directly get the chunk itself, it gets assigned, and it gets evaluated as the expression. So now my code is much more elegant. I'll show you a couple more examples because we're running out of time. But the idea is exactly the same. So in all of these examples, what we'll see is that it just leads to much more concise code. So imagine this code, imagine you're doing a bunch of math, for some reason you need to do this, and let's say you have some code like this. You're computing some q from some c and some n, and if q is less than n, you do something. If q is not less than n, you come out of the loop. So you would have some ugly construction like this, but with an assignment expression, you can do the whole thing much more elegantly. I want to show you, I think this one is interesting. How many of us know list comprehensions and use them gladly? Okay, good. So that's more than I expected, but that's good. I like list comprehensions. So let's say let's start with the problem that we have some list, let's say, or some container which contains some data, and we'll compute some value of the data, and we are only interested, so we want to filter this data based on how it evaluates. So if it computes to some interesting value, then we save that data, we save that value. Actually, this should be, if it computes to some interesting value, then we save that value. So here we have some long code that does that, and then we say, okay, why should I bother with that? I'm a champion with list comprehensions. Let me just use a list comprehension, and you can perfectly well do this in a list comprehension. But does anybody see a problem with this list comprehension on line 9? I mean, so there's no syntactic problem. It is correct. It will compile. It will run. But what could be a potential drawback? It's calling the function twice. The function may be some expensive function. And why should we have to call the function twice? And potentially we already have the value here. So if we computed the value to evaluate the condition, why should we have to again compute the value over here? So that's again repetition, and here again assignment expressions come to the rescue. You can do this much more elegantly if you write the same list comprehension, but now you assign it to some y, and it's an assignment expression. So you simultaneously check the value, and you assign it to this y, which you can then save in your list. Okay, so then with that, there are some very interesting links that I want to show you. So as before, if you want to learn more about assignment expressions, you can, maybe this works now, I killed a bunch of stuff. No, it doesn't. Anyway, so if you want to learn more about assignment expressions, you can read the PP. There are some good websites that explain more about this. So this is very interesting. So this is a work in progress. So some core Python developers, they put out this kind of challenge, and they said, look, here's a Python source code, and if anybody can make this code shorter or better, can improve the code using assignment expressions, then please submit your pull requests. And then these threads contain those pull requests. I'll just quickly show them to you. I won't go over them in detail. So I assume, how many people here are familiar with GitHub, have used GitHub? Right, that's the whole room, right? Okay, that's good. So there's no need to go into the details of this, but you'll see essentially that here this two-line version is now a one-line version with assignment expressions. This two-line version is a one-line version, and there's one kind of extreme version here. So these 4 lines end up becoming 2 lines. So there's no new. So it's not like you'll be able to do anything new now because of assignment expressions, but you can just write more efficient, more compact, more elegant code with assignment expressions. So that's the end of my talk. If you want to talk to me further, I'll be in the community lounge, but that was it.